All right, welcome to 1.2, transformations of linear and absolute value functions. So we're going to continue with the translations and shrinks and reflections that we've already seen, but we're going to get into a little more detail and we're going to write new functions that have been translated. Okay, so before we get started, let's remember that every point on a graph has an x and a y coordinate. Now we consider our y value f of x because y changes depending on x, so it's a function of x, okay? Now the x values we also call our inputs, and the y values, or the f of x, the output, so we call that our outputs. Okay, so if we're gonna move something left and right, it's going to affect the inputs. Okay, if we move something up and down, if it's going to affect or change the y values, then we're changing the outputs. Okay, so keep that in mind. Okay, and you can see that here, in black is our parent function, f of x, y equals f of x, okay? And then if we move it left, we're changing the input. So see how you're minusing h from the input x? Okay, and then over here, here's our same parent function, y equals f of x. And if we move it up or down, we're now changing the output, which is the f of x. So we're adding the k to the output f of x. Okay, so it's a little confusing at first, but we'll do a couple examples. All right, so again, when you're changing horizontal translation left and right, remember, horizontal is, you can remember it when the sun comes up, that's the left and right, just like the horizon. Okay, the horizon is flat, and vertical is up and down. Okay, so if we move something horizontally, we are going to be changing the x values. So we're going to be subtracting from the inputs, okay? So I would write this down in your notes, subtracting from the inputs. Also note that subtracting also means opposite of. So this one's a little special. We'll be doing the opposite to the inputs, and that's what moves it left and right. So it goes the opposite of what you would think. Okay, when we move it up and down, we're changing the y values. So we're simply adding something to the outputs, and that's going to shift it up and down. All right, so let's try a couple examples. Okay, so we're going to write a function that has been shifted, translated. So here's our function, f of x equals 2x plus 1, and we're going to write function g that is translated 3 units down. Okay, so down is a vertical translation, which means we're going to add to the outputs, which is f of x, okay? So let's try that. Okay, so we have our new function, g of x is equal to our output, f of x, plus, and 3 units down would be negative 3, so we're going to add a negative 3, or subtract 3. Okay, since our output is 2x plus 1, we'll replace f of x with 2x plus 1 plus that negative 3. Okay, so our new function g of x is equal to 2x plus 1 minus 3 would be minus 2. Okay, now this one's easy to check without a graphing calculator, because if we remember y equals mx plus b, remember b is our y-intercept, 0, b. So our first graph was crossing at positive 1, and our new graph is crossing at negative 2. So sure enough, it has just shifted down 3 units. Nothing else has changed. It has the same orientation or slope. So we just moved it down 3. All right, our next example, 2x plus 1, we're going to translate 2 units left. So that is a horizontal shift. So for a horizontal shift, remember we're going to subtract or do the opposite of subtract from the inputs, because left and right affects the x-axis. The x's are the inputs. Okay, so I'm gonna run out of paper here. All right, so let's start with our new function h of x is going to equal 2, and then when I get to x, my input, in parentheses, I'm going to take my x, and I'm going to subtract my value, which if I want to go 2 units left, that's a -2. So I'm going to subtract a -2. And then I still have that plus 1 on the end. Now remember, when you subtract a negative, minus a minus, you plus it. So this becomes x plus 2 plus 1. Then I have to distribute my 2x plus 4 plus 1. So I combine my like terms and I get 2x plus 5 is my new function. All right, let's try one more example so we can get the hang of this. So if you want to pause the video and try it yourself and then check it, that's a great idea. Okay, so we have our function f, 4x minus 9, will be translated 5 units up. So up is a vertical shift, so we're going to add to the outputs, right? Because up and down is going to affect the y values or the outputs. We're going to add it to the outputs. So our new function g of x is equal to our outputs, our output f of x plus 5. Okay, so I substitute our output f of x is the same as 4x minus 9 plus 5. And then I combine my like terms. So g of x will equal 4x minus 4. And again, you can check this in a graphing calculator or on Desmos, compare your new function to your old function and see if it indeed went up 5 units. Okay, next we're going to translate 1 unit right. So right would be a horizontal shift. And remember, with a horizontal shift, we're going to subtract from, horizontal affects is the x's. The x's are our inputs. So we subtract from the inputs. And remember, this is the opposite of where we subtract. Okay, so we have our new function, h of x is equal to 4. And then when I get to my x, my input, x, I'm going to minus a 1, a positive 1, minus 9. Okay, so this quantity x minus 1 is being multiplied by 4. So first I distribute 4x minus 4 and then minus 9. Combine my like terms, and my new function is 4x minus 13. Great.